right, people are filing in, but I have a lot to say today, so I'm just going to go ahead and jump in, find a seat as you please. Hi, welcome, it's good to be back. My name is Christina Lee, and I am presenting today Reflections on a Year with Compose. To be honest, though, a better name for this talk was probably Mistakes We Made, so you didn't have to. You're welcome. Now, as with any talk that involves company work, I am just one person representing an entire team of work. If something sounded goofy, you can probably blame me, and if it sounded wise, it probably involved a whole lot of my coworkers. I have to say, I'm actually pretty nervous to give this talk. I have not given a quote-unquote non-technical talk, actually, since Google I/O a couple years ago when I was talking about this new programming language that was supported on Android. So it's a pretty full-circle moment to be back today. There's another reason I'm nervous to give this talk too, which is that usually when people are invited to conferences to give case studies, it's because they have really cool things to share like this. They have glowing headlines about what a success their integration was, and they want to share it with everybody so that you can also know how successful they are. Now, you've heard the title of this talk, so you know that this is not the story that I am here to tell. Unfortunately, the story that I am here to tell is how we tried for a year to do something and we fell flat on our faces. Now, most people don't tell these stories because secretly anybody who steps on stage wants you to come and work for their company. I know, shocking, shocking. Now, when I submitted this abstract, my company was in a hiring freeze, so it was okay. Even if you thought you were ridiculous, or we were ridiculous, you couldn't work for us anyways. For better or worse, we're no longer in a hiring freeze, and so I feel obligated to add a little asterisk at the end of this presentation, which is that this is the only time code we've written has not worked. Every other code we've written has been perfect, and our code base is sterling. It shines. So just keep that in mind today. Joking aside, I am giving this presentation because I believe there is value in it. It is so much easier to see what went wrong when you are studying someone else than when you are in the moment yourself. I felt that when I was writing these slides and thinking, how could I have missed that the first time? The reason I missed it is that I was in the moment and I was focused on problem solving and I didn't have this step back of perspective. One of our company values is that we win or we learn. We set out and we do the thing that we tried to do, or at the very least, we take away new learnings that will make us better the next time we try. So that's what I want to do today. Now, inside of our company, when we run postmortems, we do it in a format that has two parts. The first part is that we try to clear-headedly document what happened. Just be objective about how things played out. And then after that, we have a section where we try to learn from what happened. We ask ourselves the questions about what went right, what went wrong, where we got lucky, and how we can do better in the future. That is the same format that I'm going to take for the talk today. First, I'm going to just tell you what happened and how it played out and why. And then I'm going to share with you 7 takeaways that we had from the year we spent trying to integrate Compose into our code base. Now, I have one caveat before we begin, which is that many people heard the title of this talk and assumed that I would have a lot of bad things to say about Compose. That is not the case at all. If you are here expecting juicy gossip about the ways that Compose isn't a great framework, you are going to be sorely disappointed because there is not a single slide in this deck that says anything to that effect. We received so much help from the Google team in this integration. We are still very bullish on Compose, and it bears repeating that just because one technology didn't work out for one company at one point in time, doesn't mean there's anything wrong with that technology. It just means that one technology did not work out for one single company at one single point in time. With that, we can go ahead and start at the beginning, which is, why do we generally adopt things? Now, I work in a capitalist society, so the answer is clear. We do it to make the company better. And by make the company better, I mean make it more money. Now, the way you can do this is usually twofold. First, you can make the product better. If you have a widget, you can make a shinier widget, a bigger widget, whatever it is. Second, you could improve the process for making that product. So instead of 4 widgets an hour, maybe now you're making 5 widgets an hour. Now, when it comes to certain technologies, you can actually get both benefits. And I would argue that the language that has brought us here today is one of those technologies. When we adopted Kotlin, it solved a crucial use case for our users that kept them from experiencing crashes. And then also, as we all know, because we've traveled all this way to be here today, it made development a joy. So in both categories, Kotlin was providing value. When we applied this lens to Compose and asked ourselves the same question, I think that there is a case for, again, making arguments in both categories. But my personal stance is that if you tried to sell Compose based on how it improves the product, it would be like trying to sell this house based on the fact that it has new plumbing. Now, if any of you own a house, you know that's actually very, very exciting. But also, if you saw a home like this, you would realize that you could probably close the sale by highlighting some even higher brow things like the view, the pool, the architecture, any of those easier to see and appreciate aspects. So, when we asked ourselves this question with Compose, there was a very clear winner, even though you could make a case for either. And that was that we went heavy on the fact that we wanted to adopt Compose because it would improve the process of making our app. Now, this is not a hard case to make, because Compose offers us so much in this category. It has an API specifically designed for reusability. It has UI previews that can help us avoid the build and deploy and test cycle. And it can do things in one-line modifiers that used to take us tons of code in custom classes. The only problem is that with all of these features, we have a common problem. And that is that measuring them can be quite hard. Now, it's not impossible. You can come up with things that will loosely measure these, but usually when you try to get those measurements, they are secondary or prone to noise. Now, you can decrease the noise by doing rigorous case studies or increasing the N and doing sampling, or even rewriting the same feature twice in order to get a real clean sampling of whether lines of code decreases for a given feature. But all of those things cost money. And money is time, and people are usually not willing to do that just to evaluate whether they should bring a technology into their code base. And so a shortcut that we took, and that many people take, is that you just presume competence. And by that, I mean you take a look at the documentation, you take a look at the API, and you say, this looks like something that could save me lines of code. Or I can see how this API would allow me to reuse these components. You say, in my professional judgment, I agree that these are very likely benefits. What that allows you to do is allows you to kind of weigh all of these goods, just presuming that they are true and not having to prove them because they are hard to prove in isolation. And then you get to focus on just this other half of the equation, which is, are there any cons that would outweigh those goods? Are there any blockers that would keep us from realizing those gains? So this flips the question from, are there reasons to adopt Compose, to, are there reasons not to adopt Compose, which is a much easier thing to study, to prove, to measure. It makes your job as an evaluator so much easier. The only problem with flipping the question in this way is that this goes against our company standard. We don't want to say, should we do this just because there's no reasons not to? And in fact, our company policy is the exact opposite of this, which is that we do not adopt things just to adopt them. Now, file this slide away in your back pocket, because this is going to come back in those 7 takeaways. It's very important to note that this means that we make decisions based on business needs, and so if we cannot make a business need for something, we do not adopt it, which means we are not always as current as maybe some other companies are in quickly adopting every new framework that comes out. So, returning to that base question, though, of are there any blockers for Compose? Well, Slow. This is a very super company specific question to be asking. So saying, are there blockers for Compose makes no sense. Realistically, what I should be saying is, are there any Pinterest blockers for Compose? And when we were thinking about this and saying we want to adopt Compose, we want to do it for dev velocity reasons, what would stop us from getting those dev velocity gains and going forward with the integration? There were two main categories. First, stability, and second, performance. Now, these are industry terms. You probably have an idea of what I'm talking about here, but let me elaborate a little bit. For stability, we essentially mean crashes, but we mean crashes in fancy terms, which is to say that, yes, we care about the volume of crashes, but we also care about the propensity of crashes. We care about whether crashes are only happening on certain API levels or certain app versions or in certain countries. We cut our crash data in many different lenses, and so we don't just care if there's 5 new crashes. We care if those 5 are in a certain cohort or evenly distributed. Now, for performance, we do measure industry standard performance metrics, but to be honest, we place much more effort and interest into internal company performance metrics, which we lovingly call our pinner wait time. What pinner wait time does is it measures the user experienced performance of our app. So if someone comes to our app to see content, what that span will do is it will measure the time from when they launch the app to when they see content. Or if they are going to a form because they want to edit the form, it measures the time from when they take that intent to go to the next screen to the time that they are actually able to type into the form and do the edit action. As you can imagine, those are not numbers that we can compare with any other company because no other company builds the app that we build. Now, deep diving into these a little bit more, when we are looking at stability with our Compose integration, the main question is, does it crash more? But I would argue it's not the most interesting question. The two that follow on is, are those crashes in our control? And whether or not they are in our control, are they easy or expensive to work around? Now, the answers here, I had to put an asterisk on this slide because I knew someone not using Twitter. Twitter, I heard, is no longer popular. Using Mastodon is apparently the new thing. I knew someone would take a photo of this slide and post it without context, so I have an asterisk here. But the answer was yes with an asterisk, which is that, yes, it did originally crash more, but when we asked ourselves, were there workarounds available and were they easy to utilize or did they cost us significantly in dev hours? The answer was also yes. They were there and they were pretty easy to work around. We had a couple of types of bugs. One, we had interop bugs. So we were using Compose within recycler views, and early on, the support for that was a little bumpy for us, and we needed some assistance from Google to iron out some crashes around life cycles. Two, we had bugs that came from adopting a technology early, which is just that the features weren't implemented yet. Like downloadable fonts when we first went to use it was not present. Now it is. That was just a symptom of early adoption. Three, we also had a class of bugs that was due to the ecosystem not yet being ready for Compose. Turns out that if you shipped Compose to Amazon devices, it would just always crash. That was not ideal. And then I would, of course, be remiss if I left out this lovely bucket, which is just, we didn't know what we were doing, and we did some silly things and caused the code to crash. That was also a bucket of crashers that we went in and fixed. But overall, the stability picture for Compose when we integrated it into our app was quite good. There were no major concerns for us. We were able to work through them quickly. And so we said, check mark, this is not going to be a blocker for us. Let's move on to the next thing, which is performance. This is the one thing standing between us and Compose in our app. Well, it's important to give a caveat, which is that apparently pre-optimization is a bad idea. And it turns out that if pre-optimization is a bad idea, it suggests a very key ordering, which is first that you build something, and then only then do you make it work fast and do you optimize it. Because without people using it, it is very hard to optimize. You do not actually know what the use cases are. Google was very open about this when we were talking to them about the first release of Compose, that this was not their primary focus and that performance would follow up. So it's really no shock that when we went in and we did experiments that gathered perf data on Compose, we found out that our view-based implementation and our Compose implementations were not even close to equal. I know, shocking. Now, Sorry, that just made me laugh. I put it in there, so it really shouldn't have. I knew it was coming. But anyhow, the story here, as I'm trying to make the point, is not that we noticed a difference between the view-based implementation and the compose one. That is not shocking. That is totally expected. You would anticipate this. The story here that I hope you take from the next few slides is how we handled, or rather mishandled, the information that there was a discrepancy and the deep rabbit hole that we found ourselves in trying to solve it. Now, I've put on this slide a roughly 2-scale project timeline for our compose integration. Up front, we had a couple compiler hiccups where it just wasn't happy integrating into our code base. Our code base was doing some things. We had to work through them, went relatively quickly. Then we had that stability phase that I just talked through, again, relatively smooth. And then the whole rest of that year that we were trying to integrate compose into our code base was for perf. Perf investigations for months and months on end, trying to get that perf regression to go away. And quite frankly, this was far too expensive and unacceptable use of our engineering time. Like, we really shouldn't have sunk so much time into this technology after the first couple months. But we did. And so the question becomes, why did we do that? And a key reason is because we were so convinced that we understood why there was a performance regression on compose. Specifically, what I'm referencing is something called the JIT hit. For those of you who aren't aware, a small synopsis of the JIT hit is that views ship with Android and so benefit from being ahead of time compiled. Compose, as a dependency that gets pulled in, generally is just-in-time compiled. There's some nuance here depending on OS versions, but that's the high level. And so you can imagine that if you have something that is already compiled when you go to launch your app, and then you have something that is getting compiled as your app is launching and running, the first would be faster than the second in most situations. So boom. Case closed. This must be what is driving the numbers that we're seeing in our compose experience. But I'm here on stage. You know it's not that simple. So let's go down the investigation rabbit hole that we went through. The way we set up our experiment was on a secondary screen. We did this for safety reasons because if we integrated compose into the Pinterest app and something went terribly wrong, we didn't want it to blow up our entire app experience. But this setup also gave us access to do something in regards to this AOT versus JIT investigation. And that is that we could fake AOT compilation of our compose code by inserting something into the landing screen. By doing that, we could force compose to be compiled, and then by the time they got to the secondary screen, both views and compose code would be ahead of time compiled, they would be equal, we would ride off into the sunset and live happily ever after. So if you were a very astute user of our application about 8 months ago, you may have noticed a very tiny, very bright red pixel right up in the corner. Yes, I know, you can thank my designing skills. I am out for hire now if anybody needs their app designed. But yes, we added a red pixel to our home feed for a small amount of users for a small period of time. And the reason we were doing this is that we were forcing compose to be compiled on this landing screen, so that by the time you got to that experiment screen, everything should be settled. Unfortunately, though, the regression did not go away. Now, don't get me wrong, we clawed back like 3 to 4%, maybe 5% in some cases, so it was a non-trivial contribution back into the performance of our compose experiment, but it certainly was not the large majority of the performance regression. Now, at this point in time, what we should have done was say, maybe our hypothesis is wrong. We ran an experiment that under this hypothesis should have fixed things, and it didn't. So maybe we need to reevaluate our hypothesis. Did we do that? No, audience, we did not do that. Instead, what we said is, are we wrong? Do we just not know how this works? Maybe we should try again. And so what we did was we took a whole different screen in a different part of the app, and we rewrote it from scratch using compose so that we weren't borrowing any code, so that if we had been silly and introduced a bug into that first screen, none of that would transfer over into this new use case. It's a blank slate. Surely we could not make the same bug twice. Only problem is that when we ran that experiment, we got the exact same results. Shocking. Now, at this point, we really should have reevaluated our hypothesis. We had run 2 distinct experiments that gave us the same exact data that said, your hypothesis is wrong. But did we do that, audience? No, we did not. So instead, we were sitting there thinking, maybe the users are deep linking past that initial screen and getting into our experiment screens. Or maybe the pixel is just not exercising enough of the compose dependency. We were making excuses. And unfortunately, at this same time, and I say unfortunately because it's unfortunate for us, not the ecosystem, this new player arrived on the scene. This new player was called Baseline Profile Rules. It is a great technology, but boy, it hit our company at exactly the wrong time. And why is that? Because what Baseline Profile Rules does is it allows you to specify which parts of your app should be ahead of time compiled. Now, given our hypothesis, this was very alluring. And we said, OK, we may have messed up the code, but if we use baseline profile rules, then Google is doing the coding, so it eliminates us as a source of error. It eliminates the error between the user and the keyboard. So we said, this is great. All we have to do is adopt baseline profiles, and we will know for sure whether the JIT hit is fueling our performance regression. That was a great idea, except for the fact that it turns out that baseline profile rules is a pretty tricky technology to get right and to implement. And so we spent months trying to get baseline profile rules working. And each week we said, next week it's going to work. We need to do this one upgrade. The bug fix is in the next release. Oh, we have this one piece of advice. Let's do that. So for months on end, we went down this rabbit hole of trying to get baseline profile rules to work. And during this time, we left a bunch of projects in chaos. For instance, during this time, we committed to using Compose in a UI components library as soon as the performance regression resolved. But the performance regression was dragging on. And so then we had to regress on that decision to put Compose in our UI components library because it was halting that project in the fact that we had not yet resolved it. So at this point in time, a very wise woman who happens to be the tech lead for Android at Pinterest and one of my favorite developers of all time said, enough is enough, team. Like, this is dragging on for too long. We can't keep committing good eng hours after bad on this. We need to sit down and have a talk. And what she pushed us to do was say, forget about solving the regression. Just tell me, what do we need to know about the nature of the regression to make a call on whether we should push our Android developers onto Compose in our code base? So we had that meeting, and the team came up with 5 questions. The first, does the regression scale with the size and the complexity of the UI, or is it constant? 2, is the regression incurred on every visit to a screen that contains Compose, or just on the first visit to that screen? 3, is it different on different device classes? The regression would matter to us in a different way if it was only affecting a certain device class versus if it was affecting every user equally. 4, how does it affect scroll performance in our app? Scroll is a crucial use case for our application, so we are very interested in this. And 5, do we have evidence that the regression caused by Compose is directly impacting our business or revenue metrics? Now, again, these are so company specific, and I don't expect anybody else in the audience to have the exact same concerns as us, but these were the 5 questions that we needed to know about integrating Compose in order to make a confident decision about it. And so when we had these questions, we were able to swap over from this focus on fixing the regression, which we hadn't been able to do for 8 months, and we're waiting on baseline profiles and trying all these things that weren't working. And instead of trying to fix it, we could kind of set that aside and say, let's just define the problem space. Now, separately, in this same meeting, that same tech lead urged us to be more aggressive. Be aggressive. Be aggressive. I hope nobody saw that movie. OK, it's fine. It's fine. I thought it was funny. And so we channeled our inner swan, and we got more aggressive. And what I mean by that is that, Remember how we set this experiment up on a secondary screen? Well, that set us up for a pretty shallow version of learning. And the reason for that is that that secondary screen didn't have all of the pressure of our primary screens. So even if we had introduced Compose on that screen and figured out what was wrong on that screen, and then said, hey, Android at Pinterest, you can all use Compose, ready, set, go, if the team that worked on our more sensitive screens came to us and they said, you're sure we can put this on our most sensitive screens? We would say, no, we are not sure. We did not study it in that case. So we were going to get half of an answer to our question because we weren't studying the worst case. We were studying the safe case. And so what did we do? We took the experiment to the worst case. We decided that we wanted knowledge on what the upper bound of this regression or the stability issues would be for Compose. And in order to do this, we had to be okay shipping imperfect UI. Although I wouldn't call that red pixel imperfect. I think it's rather a work of art myself. But in order to get a perfect UI, it would have taken us months to replicate the exact components that were on that landing screen, and that was just outside the realm of possibility. So instead, we literally put little rainbow pixels all over that screen. We did just good enough approximations of different components where the user probably never noticed the difference, but technically they were not one-to-one. And then we adjusted our statistical analysis to account for that, because obviously as things shift on the screen, it can muddy up your data. The thing about this, though, is that it worked. We got information so quickly because that primary screen also had a huge volume of users flowing through it, so we could get data back in days that used to take us weeks to get statistical significance for on some of those secondary, less trafficked screens. So what decision did we come to? Well, you already know this ending, but we decided that we could not put our full weight behind Compose for our organization. That was, again, because we could not, or the data that we got back for the performance regression indicated that it was going to have a significant impact on our business metrics and what we cared about as a company. So we did not have a business case to do it at this point in time. That said, we had already written Compose in the code base. We had some enthusiastic early adopters who really enjoyed it. And so we said, we don't think it's to the point where you have to tear out that code. So we allowed the code to stay there. And we said, if you are particularly enthusiastic and you want to continue writing in code and you can justify it in your feature, go ahead, but the platform team is not going to give you first-class support. We're not going to wrap all of our Pinterest internal frameworks like we would normally do for a new technology. We cannot be your support and guidance on this. You would be taking it on your own. That said, though, we do strongly still believe in Compose, and so we did not want to make that call and then stagnate. And so in order to make sure that we did not stagnate, we also committed and set up reminders that would ping us every quarter or every new Compose release to rerun this experiment, to regather the data, to check if performance had gotten faster. In addition to that, we also set up an exploding deadline, which was that if after we were rerunning those experiments every quarter, we still had not made the decision to adopt Compose because there was still a blocker, and we reached this point in time, we were saying, no. We need to move forward. We cannot stagnate at that predefined cutoff. We were going to adopt Compose, or we will adopt Compose, even if those metrics are still there. Because at some point, you do need to move the business forward, and you cannot be held hostage to your metrics or to trying not to rock the boat. So that's where we landed, and that is a synopsis of what happened. In terms of what did we learn, this is the fun part, because this is where we get to catalog what went wrong. Now, like I said, I have 7 takeaways. The first, and probably the most important, is that we really lacked some self-awareness as a company, which is that we did not recognize that a key defining trait of our engineering org was that we care about performance a lot. And in fact, we just assumed that every other company we were talking about cared as well. And it turns out that actually, now that I've started asking this question, I have not talked to any of my peers that had the same performance use case that we did. So we had done the right things. We had gone to our peer group. We had asked them how they were adopting Compose and in what ways they were adopting Compose. And we were getting that information and saying, oh my gosh, okay, like I hear what you're saying. Sounds hard given this information, and we just assumed that because they were doing it, they had seen the perf regression and fixed it, and we were the only ones that had a problem. It wasn't until 6 months into this process that I explicitly asked some of our peers, how are you handling this issue? And they said, oh, performance doesn't actually matter that much to us. And that's not because their engineering culture is bad or wrong, it's because their business use case is different. If you are an app that sends money or moves people or deals with medical records, it turns out you can make your app slower and people still have to pay their bills, they still have to get to work, and they still need to hear about their diagnosis. And so they are incredibly robust to performance in a way that the Pinterest users were not. So we had this mindset about the data that was coming into us that was completely off base. Second, if we had this self-awareness, we could have anticipated this performance crossroads from the get-go. If we had thought, we are a company that cares a lot about performance, Google has told us that performance is not the primary focus of this library for the 1.0 release, although it will come later, we could have known immediately that we were always destined to reach this problem. And the benefit of having known that in advance is that we could have planned instead of reacted. When we reacted, we spent months trying to chase a fix that was so elusive that we never actually found it. Instead, when we planned and we gathered only the necessary data, we got our answer within 5 weeks. If we had been able to skip that step of the rabbit holing and just go straight to those 5 questions, this wouldn't be a talk I was giving and being embarrassed by at Kotlin Conf. Takeaway number 2. In the absence of external validation, we assumed that we were wrong. And again, this builds off of point 1, which is that we lacked confidence because we were operating in a void. And this is true of any new technology. The ecosystem is different now, but at the time we were doing this a year ago, there were no blog posts of anybody talking about Compose performance. Again, we were talking to our peer companies, at least 5 of them. They were giving glowing reviews, saying they were Compose first, they were loving it, they were having no problems. And so when we were hearing all of this coming back, we just thought, we must be the only people in the world who don't understand how to use Compose. And it wasn't until we asked the crucial question that we realized that wasn't the case. We just were operating in a void and got prone to second-guessing ourselves. Oh, and that's what led us down the rabbit hole. 3, we prioritize learning safely over learning quickly. And that is costly. It's reasonable in some cases, but it's also costly. As I mentioned, by going to a secondary screen, we set ourselves up to learn half the information that we actually needed to know, and then we had to start over and go back to the screen we actually cared about in order to get the full picture. And that's not even mentioning the fact that when you're experimenting on secondary screens, you're getting a lower flow of users and you're not stress testing it fully. So it turns out that one of my biggest takeaways is that learning quickly is worth a well-calculated gamble. And this is a mistake that I am swearing to myself that I will not make on a future technological integration. 4, we got distracted by external advice. And I already covered this a little bit on the perf aspect, but in this respect, I actually want to call out specifically the fact that every company that we talked to seemed to be adopting Compose in a design library. Also, we talked to Google, and they said, hey, this would probably be a good idea. Maybe you should look at it as well. So we were hearing from many angles that Compose would be great for a design library. And I can see why we got that advice and why people were saying it, which is that design libraries showcase Compose's API perfectly. Like, if you want to see how great Compose's API is, a design library is the ideal sandbox for it. It shows it off to perfection. The only problem with that is that a design library, by design, is meant to be everywhere all at once. Your design library is not terribly effective if it's on one screen. If it's working, it's in all your screens. That button is in all the screens, and it's the same type of button. It's the one from your UI components library. What that means is that when you introduce a new technology via the vehicle of a design system, you are taking on any of the risks of that technology in your entire app at the same time. So in our case, for performance, if we had put Compose in a design library, we would pay a performance hit on every single screen of our app in return for putting the button on it, which is maybe not the biggest velocity win. Further, if Compose's API was tricky, which we have heard several times about the risk of doing too many recompilations and how people aren't always setting their code up for success, then you are exposing that tricky API to every single dev in your org all at the same time. Now, maybe for some orgs that's desirable. You just want to rip the Band-Aid off and take on the whole problem at once. But we run very lean, and that's a pretty daunting task for our platform team to take on, to educate everybody at the same time, to regress the performance of the app in every screen all at once. That was a hurdle that we could not clear, and yet we had committed to going in this direction because it seemed like this was the agreed upon way to introduce Compose into applications. 5, we compared something easy to measure to something hard to measure. Now, this is where this slide that I used in the beginning comes into play, which is that when we switched our perspective from trying to prove the benefits of Compose to just trying to rule out any of the blockers, what we did was we set ourselves on a collision path for using hard statistical data for those blockers, which we had in a dashboard that was blaring red, that was being reported up the business management train because they always monitor these dashboards. We set that up on one side of the equation. And on the other side of the equation, we said, Compose is good. Like, we believe that it will work, and if people use it, they will, sprout wings and be happy, and everything will be euphoric. But we didn't have any proof of that. It was just an amorphous blob of good feelings that we assumed would be true. Now, human nature is such that if you come in with statistics about how something will harm your org, and on the other side, you only have hand-wavy expectations that things could maybe possibly get better, probably, you are probably far more likely to give way too much weight to the negative or to the thing that is concretely measured than you are to give to the positive. And we very well may have made the wrong decision only because we can measure one side of this equation far more easily and far better than we can measure the other side. Maybe adopting Compose would have been the best call for our company, but because we couldn't measure the positive, we gave too much credibility to the negative. 6. We did not make sure the basics were in place. Now, I did not reference this for time in the synopsis of what happened, but if you remember this brief call out to our policy that we do not adopt things just for the sake of adopting them, this is where this becomes relevant. Because it turns out that Compose has coroutines first APIs, and also that it thrives on UDF. Our code base did not widely use coroutines because we had made a decision that it didn't meet our business needs at the time. And also, we were using MVP and not UDF. And so that meant that our prereqs were not in place. And so when we got to our decision doc for whether we were going to continue investing in Compose, we already had a murky decision because of the perf data. And then on top of that, we were layering this extra organizational cost where we weren't actually adopting Compose. We were adopting Compose and coroutines and UDF all at the same time for everybody. And when you get a large org, you start to have a real appreciation for how hard it can be to move dozens of engineers onto a new technology, let alone three of the magnitude that coroutines, Compose, and UDF represent. This is not an easy task, and so that was just one more check where if we had stopped and thought about this in advance, again, we would have said, we need to finish those 2 projects. We need to move on to UDF, which we had already started. We need to get on to coroutines, which we had already started before we had tried to adopt Compose. And then lastly, we missed a very crucial part of adopting a technology specifically for dev velocity reasons, which is the highest ROI for dev velocity usually exists on your riskiest screens. You saw that our policy left the Compose code in our code base. We talked to several peer companies who also adopted a policy that Compose was fine just in greenfield screens and not on their primary ones. Now, that's fine, but we need to be real with ourselves that if we're adopting Compose in that way, we are not getting dev velocity gains. Because probably if we're adopting it into the settings screen, maybe one engineer once a month is going in to fix a bug. So if they get faster in fixing that bug and they save themselves 5 minutes, great. But in the meantime, we have 30 engineers who are working on that landing page, committing to it daily, and we are not saving them any time. And so the 5 minutes of that one dev once a month, that does not move our organizational dev velocity needle. That does not accomplish the goal of speeding up our org. It just says, composes in the code base without getting us those wins. So that was what we learned from my perspective. In these last few minutes, I just want to take that and twist it a little bit for the outward lens, because I know this was all very Pinterest specific. So in terms of what I hope someone from the outside looking in takes away from this, one, I hope that you saw through our mistakes the importance of the self-awareness of knowing what your company values. Like I said, and like you've seen throughout this presentation, for us it's performance, but I imagine for a company dealing with money or medical records, for them, the rightness of their code, the correctness of their code is like a line that cannot be crossed and that they would do anything to optimize for. Because for us, if a button press goes wrong, the user goes to the search page instead of the scrolling page, or they go to their profile. The world does not end if we get our logic wrong. If someone writing a money-based app gets their logic wrong, money disappears into someone else's wallet, and it turns out that is a bad thing if it is not the wallet that is yours, that it is appearing in. And for everybody else, they do not like disappearing money. It's a regulatory nightmare. So being aware of what you care about is important. Also, we spent so much time on the wrong track because we did not apply the same lens to our peer companies. I loved that we worked so closely with our peers in the year that we were trying to adopt Compose. We got such great feedback from them. We appreciated their time and conversations. But we were completely missing the fact that they did not have the same business use cases as us. And so when they were saying that they were adopting it in this way and they were seeing this problem, we were not applying the correct lens, and we were going off course because of that. It's not that we should not have been talking to them, it's that we should have contextualized the conversations that we were having with them. So I hope you also have an appreciation for that. Third, set acceptance criteria in advance. This is business 101, but like I said, once we saw problems, we got into a reactive state of mind instead of a strategic state of mind. What we should have done was have the self-awareness that if we were evaluating stability and performance, we might find problems in either area, and have set criteria. Stability can regress by 1%, and we will still move forward with this. Performance can regress by 2%, and we will still move forward. Instead, we did not set those recs in advance, and so we saw stability issues, and we said we should just fix them all immediately, and we did. And we were lucky because it didn't cost us that much because they were easy to fix, but when we tried to pull that same trick with performance, we ended up going on a 7-month hunt, and we never got to where we wanted to be. Call out prereqs. This would have taken us 30 seconds, and yet we didn't do it, and it cost us. So again, Business 101, it sounds so obvious from the outside. It's hard to even write it on a slide, but I work with a team of smart people, and none of us stopped to do that 30-second due diligence to know we really should have finished our coroutines project and our UDF project before we ever started with Compose. And we didn't, and we paid the price. And, actually not last, we have one more. If you're going to set out to learn, fully commit to it. We, again, prioritize safety over speed in learning, and that's not great for our users either. Sure, a red pixel on screen, as delightful as it is maybe not ideal, but realistically, none of our users probably notice that. They see what they expect to see. And in the meantime, that we were learning slowly, we were not shipping a bunch of updates that we could have been that would have reduced their network load or improved their battery life or done any of these other things that day-to-day we spend our time doing to make our users' experience more delightful. And then lastly, and most importantly, I hope the takeaway that people have is the dangerous nature of comparing something easy to measure to something hard to measure. I don't know what the fix is here, but I think if you approach it with awareness, you can find one. And so while I cannot give you a solution and say, here's how to fix human nature and get people to equally weigh nebulous things with concrete things, there are ways that you can strategize. You can have conversations with your management team in advance, just acknowledging that this is happening. You can do a couple of problem-solving things, and I will think more about them, but we did not in this project. And again, we paid the price, and we way overemphasized on the concrete. And maybe that was the wrong decision. I will never know because the decision is what it is. Now, that was all I had for you today. I hope that we embodied the win or learn mentality, which is that I did not win, but you learned. Thank you so much for joining me today, and don't forget to vote. Thank you all.